Hey guys, what's up everybody? Welcome or welcome back again to another video tutorial from the Apex Academy of Mathematics, where learning the language of the universe begins here. And on this channel, we help students to master their fundamental ability. We rebuild them and we unlock the genius that is already within them. All right, now my name is Akin, otherwise known as Apex Selenium, and if this is the first time here on my channel, of course please go ahead and hit the like button, of course smash that subscribe button below, and turn on your post notification bell for future video tutorials. All right, now by the title of this video, you can clearly see that we're going to be discussing what are the different types of numbers. But of course, this topic here is a fundamental video, but it is to the benefit of CSEC students, CAPE, City and Guilds, and all the other different types of examinations. All right, definitely kids can also watch this video because it's to also their benefit. All right, now of course on this channel we also help students with CSEC exam papers. We help students with GCE, ED, Excel exams, SATs, and all the other different types of exams that exist out there. So please go ahead, leave a comment below if you like the video and the production of the content, and of course you can make video requests below, and check the description box below if it is that you need to watch any other videos. The links are provided below. Okay, all right, good. So let's just jump right into the video. So we're going to be talking about the different types of numbers, and of course, as I would assume that you probably already know what these are, but there are some interesting facts that I want to share with you. So let's go right ahead. All right, so I have some definitions here for you for odd numbers, and let's jump right into it. We say that odd numbers are a set of numbers that which when you divide them by 2, it always leaves a remainder of 1. All right, so it is denoted by the symbol O. All right, so O is what we use to determine the numbers that are odd. All right, and these numbers, of course, you're familiar with them. They are 1, 3, 5, 7, 9, and by now you would have already picked up a pattern that the next number would have been 11, 13, 15, 17, and it goes on and on until we reach, or it goes all the way to infinity. All right, now also I need to mention to you that listing the odd numbers are infinite. You're not able to list them unless a condition is given. Say for example, a question may say list the odd numbers between 40 and 90. Then that's the only time that you can that's the only time that odd numbers are finite. But if you're asked to list the odd numbers, then of course the answer is infinite. Okay, all right, so that should be quite clear for you. If you don't mind me demonstrating here for you, right here on the screen, we have, like, say for example 5 divided by 2, that will always leave a remainder of 1. It will go 4 times, leave a remainder of 1. All right, and of course every other number that is here, you can try testing them, dividing them by 2, you're gonna always see a remainder of 1. All right, good. So let's look at what are even numbers now. So even numbers are a set of numbers that which when you try to divide them by 2, it has no remainder. So 2 goes exactly, or is exactly divisible into what we refer to as even numbers, and of course it is denoted by the symbol E. Okay, so E equal the set of, as you can see here, 2, 4, 6, 8, 10, and you get the pattern that it's 12, 14, 16, and so forth. So any one of these numbers that you try to divide by 2, it will go exactly into that number and there will be no remainder. All right, so I think that is quite clear enough for you for what are even numbers. All right, good. Now, one of the numbers that students often have problems identifying are the prime numbers. Not only do they have problems identifying what they are, but they also have a big problem in terms of understanding what the definition of a prime number is. All right, so I am going to go ahead and explain that for you here. All right, so it says here that prime numbers are and I added that word special. All right, it's just some special type of numbers. They are special set of numbers that they only have 2 divisible factors. which is the number 1 and the actual number itself that you're looking at. Okay, so when we say that it's only divisible by 2 factors, it means that there's only 2 numbers in the world that is exactly divisible into that number, can go exactly into it without leaving a remainder. All right, and why did I say that they're special? Because of course we're going to take a look at this number here, number 2. All right, it is probably it is not probably, but it is the only even number. It is the only even number that is a prime number. All other prime numbers are going to be odd numbers. All right, so let me just reiterate that for you. 2, the number 2 is the only even number that we can consider to be a prime number. All other prime numbers will be odd. Now I need to make a very important notation here, as I've written here in red for you right here, that says all prime numbers are odd. All prime numbers are odd. Of course we said that with the exception of the number 2, but in reverse, not all odd numbers are prime. Now what does that mean? If we say that all prime numbers are odd, it means that if we are to list all the prime numbers, which of course again is infinite, you're going to be an odd number. But if there are certain odd numbers that if you try to check and see if they are prime, they are not. Here, take for example the 9. 9 is an odd number. And of course, when you check to see if 9 has only 2 factors, you're going to find out that 9 has 3 divisible factors, which is of course 1, 3, and 9. Take for example here again the number 15. Yes, number 15. So 15 here, yes, has it's an odd number, but it can be divided by 1, it can be divided by 3, 5, and it can be divided by 15. So of course 15 is not an odd number. So it's very important you understand that a prime number is a number that only has 2 divisible factors. 2 divisible factors, that is only 1 and the number itself that can go into it. Yes, However, there are certain odd numbers that are not necessarily prime because they have an additional divisible factor. All right, so I hope you guys got that. I've given you a list here, 2, 3, 5, 7, 11. It's really important for you to actually learn, at least memorize the first set of prime numbers that lie between 1 and 100. All right, this is very good when you're doing topics like sets, because they do ask you to pick out numbers from the list. All right, so it's really good for you to know those numbers. All right, so good. I hope you got that, guys. So far I hope you're enjoying the video, and if you are, please of course go ahead and smash like on the video, turn on that subscription button, and of course turn on also your notification bell to support my channel. All right, I have so much more to offer you here, so let's continue this video. Now also, I want you to realize here for me, I want to just bring this down a little bit here. All right, so we're going to talk a little bit about composite numbers. All right, composite numbers. Now, this is one of the most underrated and of course ignored numbers, or set of numbers. Right, we don't usually talk about it. You usually go through a textbook and you normally meet up on its definition, but no one really talks about it. All right, especially at the fundamental level, it is just ignored. All right, but I'm here to expose, not expose, but of course let you know, enlighten you about certain other concepts that you might never have known about. So composite numbers are what we say are set of numbers that have more than 2 factors. All right, now when you read that, that sounds like something opposite to something. Yes, composite. Now earlier we said that prime numbers are numbers that have only 2 factors, only 2 divisible factors, but now we're saying that composite numbers are numbers that have more than 2 factors. So that, to me, based on reading and understanding, is that these are, or this is the opposite of what a prime number is, because a prime number has only 2 this has more than 2. So clearly you can see that composite numbers are numbers that have more than 2 factors, which clearly we can see that it is the opposite of prime numbers. All right, so that's why I've written here, usually composite numbers are basically the opposite of prime numbers. And we do have some examples here for you. All you have to do is that if you know what your prime numbers are, then all the numbers that you did not list, as a prime number, those missing numbers will be called a composite number. All right, I also refer to these numbers as rectangular numbers too. And I just want to go to the next page here, and I want to show you why I call them rectangular numbers. Take for example the number 4. All right, the number 4. Now 4 is an even number, and 4 is a natural number, and 4 is a whole number, but it's also called a rectangular number because I can say, for example, 1 times 4 will give me 4. Now I can make a rectangle here. Okay, 4, 1, and of course I can make here, well, 4 is more like a square number. It's not so much like a rectangular number, but of course a square can also be considered as a rectangle. So what that is trying to say here is that I can take an arrangement. Okay, I can take an arrangement of 4 and create a rectangle from it. All right, so 4 is not the best one, but let's look at a different number. Let's say, for example, the number 6. We can arrange, 6 is not a square number, but it's a rectangular and a composite number, right? So I can take the arrangement, say 2 and 3, and I can put 2 dots at the top and 3 dots at the side. Okay, and that will form a rectangle. So it is 2 by 3, and notice that I'm creating here a rectangle. All right, isn't that nice? Yes, that's nice. So I can take another number, let's say 8, and I can arrange 8 as 4 times 2, or even 2 times 4. So I can take 2 dots and put it here, and take 4 dots and put it at the side, and then that will create for me a rectangle here. 2 at the top, 4 at the side. I could even put 4 at the side and 2 at the 4 at the top, and 2 at the side, and I can also still create here a rectangle containing 8 dots. All right, so clearly you can see here that this number is called a rectangular number. All right, so do check it out. You can go on the internet and check out what we refer to as being rectangular numbers. All right, fantastic. So I'm happy that you got that, guys. Now we are going to jump into the real juicy part of this video here. Real juicy part. This part is where we call the square numbers. And we say that a number is said to be a squared number, or what is referred to as a perfect square, if one of its factors can be multiplied by itself twice to give the same number. All right, and of course this is probably one of the most important numbers, right? Of course these numbers are very difficult to memorize, especially if you're a beginner or you are first exposed to these numbers, but over time, by using them and by seeing them, you become familiarized with them, and of course you're going to learn even later on that the perfect squares are going to be a useful tool in, of course, manipulating the exponential quantities and so forth. All right, I do want to show you some special numbers that you need to pay attention to. There is a video that I'm going to be making that is called the manipulation techniques of exponential quantities. Do of course check the description box below for a link to that video. All right, so do check it out. But let's take a look at these numbers. It is listed here as 1, 4, 9, 16, 25, 36, and I've also here made a chart for you starting from 1 to 30. Now my advice is that you try your very best over time to learn the first 25. The first 30 is good, but the first 25 is more useful than anything else. All right, you need to make sure that you know the first 25. Knowing the first 25 will give you a serious advantage, especially in topics where you have to be simplifying exponents or solving exponential equation. Of course, there is videos on my channel on solving exponential equation. Do check the description box below for a link to that video. All right, so of course I'm really happy that I can help you with this. All right, so here basically what we're saying here is that each of these numbers here, they all have factors. They may have only one factor, maybe two factors, but more than likely they are going to have more than two factors. And what these numbers do is that there is always one of its factor that if you are to find that factor and multiply it by itself, you're going to get that very same number here. Take for example 4. There is a factor of 4, say 2. If you multiply 2 by 2, you get 4. For 9, you take the factor 3. 3 times 3 is 9. The 16 has quite a few factors, but for 4 is a factor of 16. 4 times 4 is 6. 5 times 5, 25. 6 times 6, 36. And you get the whole idea here. So this is one way of, or this is the way that we write squared numbers with a 2 at the top here. That 2 is suggesting that the number is squared, and these are the numbers. So get familiar with them, because you're going to be seeing these again and again and again, especially in a lot of my videos where I won't be demonstrating the principle, but I'll be sending you to watch videos where I've explained manipulation techniques using these numbers. So please familiarize yourself with these numbers. All right, wonderful. Okay, so here we're going to be looking at cubed numbers. All right, so cube numbers are basically numbers that are numbers which also have one of its factor, which when multiplied by itself, this time we multiply by itself 3 times, then of course we're going to get the very same number. And here are some examples that we have here for you. Yes, we have numbers 1, 8, 27, 64 and 125, and it goes on. I've created a list here for you for the first 10 numbers, but it's really when I'm teaching, I really like to tell students to, you know, kind of extend your potential a little bit and go all the way up to 15, but the first 10 is the most useful. Right, so we have 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and it goes on like that. All right, so really good to know what these cube numbers are. It's basically numbers that you multiply by itself 3 times and it will give you the very same number. All right, so what I want to do right in the last part here of my video is to show you a really nice technique here, is that cube numbers and squared numbers, they are somewhat connected. There are some special numbers that you need to look out for. All right, take for example here we have the number 8 squared. That's 64, but if you go across to my chart over here, you're gonna find that also 4 cubed is 64 too. So there are numbers that are cubed that are also have other factors that are also squared. Yes, so you need to look out for numbers like that. All right, there is a really good connection with these numbers. All right, now also I needed to pay attention to the fact that these numbers can be expressed in different forms. All right, take for example here we have the number 64 here, and 64 we know that it is 4 cubes is equal to 64, and we know that 8 squared is equal to 64. All right, now since we know that 8 squared is 64, let's go right over here. Since we know that 8 squared is equal to 64, all right, we know that 8 is actually 2 times 2 times 2. Yes, and that is also basically squared right there. Okay, because 2 times 2 times 2 is 8, and that's 8 squared. Now if we are going to use the power property here, we can say that the power to power property is that the power here distributes itself to each of these numbers. So this is basically 2 to the 2 multiplied by 2 to the 2 multiplied by 2 to the 2. All right, so there now we can see that we can use the multiplication property of indices, and that states that we're going to add the powers here. So 2 to the 2 times 2 to the 2 times 2 to the 2 is really 2 to the 2 plus 2 plus 2, which is equal to 2 to the 6. So this is another way of expressing the number 64, all right, as an exponential quantity. So you really want to take a look at that. All right, so here you can find that 2 to the power of 6, 64, 4 cubes is 64, 8 squared is 64. All right, so you can see that 64 can be expressed in different ways. All right, let's see if we can find another number that is similar to 64. All right, it's really good to know this. I do have a video that is coming out as it relates to looking at squaring these numbers like that. All right, so let's see if we can find another number that is really good. Let's take a look at the number 81. All right, we know that, of course, 9 squared is equal to 81. Yes, but we know that 9 is actually 3 times 3. Yes, and that is also squared. So using the power property here, we know that this is basically 3 squared times 3 squared, and that's equal to, according to the multiplication property of indices, we know that we're going to add the power. So 3 squared times 3 squared is equal to 3 to the 2 plus 2, and that's equal to 3 to the 4th. So here you're seeing that 81 is equal to 9 squared, and also 81 is equal to 3 to the power of 4. All right, so guys, with examples like this, I do want to do another one for you. I don't want to just leave you like that. There are many more. All right, but I do want to take a look at the number 729. I want to take one from this side here. Okay, 729. So we know that basically 9 times 9 times 9 is equal to, of course, what we see here is 729. But we know that based on the fact that 9 is not only just 9 times 9 times 9 is not just a cubed value, but of course 9 is also a squared number. So 9 can be turned into 3 squared, and this 9 can be turned into 3 squared, and this 9 can be turned into 3 squared. Of course, we know that using the multiplication property of indices, we know that this is going to be 3 to the 2 plus 2 plus 2. So that's equal to 3 to the 6. All right, so here you're looking at the fact that 729 is equal to 3 to the 6. 729 is equal to 9 cubes, and later on you'll find out that 729 is equal to 27 squared. All right, so this is also really good practice to experiment with the numbers. Remember that there are many numbers that have different powers, to the power of 4, to the power of 5, to the power of 6, to the power of 7. These numbers, is really difficult to memorize all of them, but what you can do is learn the basics of squared and cube numbers and learn how to manipulate them. All right, now if you want to know what I was referring to down here as the multiplication and division property of indices and all these kind of properties, do check the link, the description for the link below to that video, and so much more. All right guys, so I really thank you for staying all this time here. If you have reached this part of the video, you are going to be blessed and you are going to unlock that genius within you. So do take care, and thank you for watching, and I'll see you next time in another video tutorial. Goodbye.